This is leftover material from CSC 230 from our lecture on Wednesday. We didn't get quite through the material on assembly language. So if you want to get started on the exercises earlier, I thought I'd record a little short video covering the leftover material. We'll do this at the start of class on Monday. So you don't have to watch this, but it might let you do the exercise early if you want to do that. This is where we left off. We're talking about if we want to write assembly language that can work with C, or if we want to follow the calling conventions for the x86-64 processor on the common platform, then here we were talking about how to return a value from a function. And the quick answer is, if you just want to return an integer value, the AX register is the right way to do that. If it's a integer value or smaller, you can return it in the EAX part. If you need a pointer or a long integer, you can return that in RAX. And this is the example I think we ended class with. In C, if you want to call a function in assembly language, then you need a prototype for that function. And if you have a return value for that, the prototype needs to include that. And over in assembly language, if that's how we want to implement this function, we have to advertise it. We have to make it available outside this compilation unit with a .global directive. And then inside the function, we just need to make sure whatever value we want to return, we put in the AX register. Here I'm returning an integer, a 32-bit int, so I can use the low part of that register, EAX. This talks about how to return values. If you have to return larger values, C lets you return those on the stack, but we won't cover that in assembly language. There's also other registers for returning floating point values, but we won't need to use that for this semester. How about inside our function? What if we want to do more than just compute a value and return it? Well, global variables, whether they're defined in assembly or C, they have a name associated with them. And in assembly, that looks just like any other label. So here I've got some C code that has a couple of global variables, 2 integers. In assembly language, I can just use the names of those globals to access their values. So here I've got a function in assembly. I've written up here what it is equivalent to in C. It just takes the values of these 2 global variables, adds them, and returns that. And I do that by just getting a value, the source operand for this first move. And for this add instruction is I just gave the name of that global variable. And then when the linker, I assemble this with the assembler. When I link it together, these names, global A and global B, will refer to these locations, even if they're defined in C, as long as I use them with the right size. Here they're integer, and when I copy to EAX, well, that's 32 bits, so it'll copy 4 bytes, same size as an integer, into EAX, and then when I add, it'll do the same thing, 4 bytes. So in assembly, I have to make sure I access the right sized amount of memory to copy it into this register. And then I left the sum in EAX, so when I return here at the bottom, it'll automatically be in the return value for this function. So over in C, if I'm calling this function, the return value will be right there where C is expecting. I started to say a moment ago, if you want to pass parameters to a function, as long as you only need to pass 6 or fewer parameters, and as long as they're integer types, then you only have to worry about parameters passed in registers. I've listed here for the C calling conventions in Linux. These are the registers that get used to pass integer parameters. So I'll read through this, but I'll try and do it quickly. The first integer or pointer parameter is passed in RDI, and then RSI, RDX, RCX, R8 and R9. The current version of x86-64 has 16 registers, so they decided it made sense to use, at least when they were doing calling conventions in Linux, they decided it made sense to pass up to 6 integer parameters using those registers. So if you need to pass pointers, you can use the whole register. If you need to pass a smaller value, like a 32-bit int, you can use just the low order part of that register. So that's what we're doing here. If we wanted to write a function that took, rather than adding 2 global variables, that took 2 integer parameters and added those up, over in C, this is the prototype for what the function might look like. It takes 2 integer parameters and returns an int. Here's how we might call it. Over in assembly, here's how we might define a function like that. We'd have to give away the label for the function using a .global directive. And then inside the function, well, if you'll let me back up a slide, the first parameter should be an RDI. The second parameter should be an RSI. If I'm passing 2 int parameters, those are just 32 bits, so I don't really need the whole register for that. So you can see here, I'm just getting the low order 32 bits out of that register. For returning the result, I know that needs to be in the AX register. If I'm returning an int, then I can put that in the low order 32 bits of AX, so EAX. So I just copy the first parameter, EDI, to EAX, and then I add in the second parameter. And then when I return, the return value is already in the register where the caller is expecting it. So there's a little bit more leftover material from lecture 22. We'll cover that at the start of lecture 23. But what we've covered so far should be enough to let you finish exercise 22. So if you wanted to get started on that earlier, this should give you a chance to do that. I'll see you at start next week, and we'll finish up this material and cover a little bit more assembly language material. I'll see you then.